you can work with the mind and you can do timeline therapy and you can do clinical hypnotherapeutic interventions. But then if you also work at the root cause, at a physiological level, those two interventions can work so well together.
This is synergistic, and they work so well together. And if you think about it, whether it's being, the hypnotherapy or any form of psychotherapy, really, if you're not in that fight or flight, you can do better therapy. If your body's in this adrenaline, high cortisol state all the time, it's really hard for you to get your mind-body connection and go into that kind of therapeutic relationship that you need with your therapist.
But from the standpoint of being quite time poor, right, which is the curse of all high performers, a curse or a gift, I don't know which way to look at it, it is just super attractive because now we're saying, get this done, we're actually working at the root cause of the anxiety, and then you will have the holistic journey of being seen by a therapist, psychotherapist, hypnotherapist. So what we've done really is work holistically from the ground up, so to speak.
Today, we are joined by the incredible Dr. Adeel Khan, a pioneer in stem cells and gene therapy and the visionary founder of Eterna Health Clinics. Dr. Adeel is leading the charge in regenerative medicine, transforming how we think about health and longevity. From cutting-edge stem cells treatment to anti-aging breakthroughs, his work is trusted by some of the world's most high-profile individuals, including Tony Robbins. And I was so lucky to meet him and hear him speak at the Copenhagen Health Week, where we were both keynote speakers. In this episode, expect to learn how regenerative medicine is reshaping aging, the truth about stem cell and gene therapies, and whether these groundbreaking treatments could be right for you. Without further ado, let's dive in and welcome Dr. Adeel to the show.
Dr. Khan, welcome to the show. I'm so excited to speak with you today. We've had the pleasure to meet at the Copenhagen Health Conference, and I just thoroughly enjoy your keynote. And I thought this is a message that needs to be heard. So welcome.
Yeah, thank you for having me and sharing the message.
I appreciate that. I would love to dive into what is regenerative medicine and how is it different from traditional allopathic medicine?
Yeah, it's regenerative medicine is kind of this holy grail concept. It came out a long time ago. I think, in the 70s is probably, or 60s even, is when the concept first came out, which was like, hey, the body can heal itself to a certain extent. So can we give it the right signals or the right tools so that the body can fix itself? And so instead of having to give you drugs, instead of having to give you surgery or cutting things out, can we get the body to heal itself? So that's what regenerative medicine is at a very simple level. Now, it's obviously become more complicated. And now the definition that's a bit more technical is combining cell therapy, gene therapy, and tissue engineering in order to restore tissue back to a previous state. That's more of an academic kind of definition, but the point is, we're trying to give your body the tools or the building blocks. We're trying to manipulate it in a way so it can heal itself.
And I think when it comes to at least the concept of stem cells, we all have perhaps an intuitive ideas of what stem cells are. And very often when I talk about stem cells with clients, it's this idea, right, it's the things that rebuild tissues and it comes from bone marrow, comes from the umbilical cord. I think we all have an idea, but we don't necessarily know deep down what they are and what they do, and perhaps the difference between the one that are endogenous and the one that can be external. Could you explain to us what truly are stem cells? Where do they come from? What are the sources?
Yeah, so basically there are multiple sources. Now, the one stem cells that are most popular and the ones that most people use are something called mesenchymal stem cells or mesenchymal. But mesenchymal stem cells is because it's an embryological term, but essentially what people need to understand is that these stem cells are easy to find. And that's the reason, that's number one reason we use them. Number two reason is because they don't cause cancer. And because the problem with, for example, embryonic stem cells, where you get them from fetuses, those stem cells can cause cancer or tumors. whereas mesenchymal stem cells we know don't, because they only have a finite ability to differentiate or replicate. So meaning they only grow so much and then they stop. So that we know, and mesenchymal stem cells have been around for over 20 years, since over 30 years now. 1992 is when they were first discovered. So Arnold Kaplan came up with the name, and in 1992 he named it mesenchymal stem cells. But in 2017 he wrote a paper saying that it should be maybe called medicinal signaling cells, because they're not really regenerating tissue, they're sending signals to reduce inflammation. And that's, if you go to like any other stem cell clinic as of now, they're using mesenchymal stem cells typically from umbilical cord tissue. You can isolate it, like you said, from fat, from bone marrow, from dental pulp. There's other sources. But the reason we like umbilical cord is because logically it hasn't gone through any replication cycles, right? It's fresh. It's new. But the stem cell has an ability to, like you said, to repair tissue, but it also has an ability to turn into new types of tissue. But a mesenchymal stem cell, it turns out that it's only multipotent, which means it can only turn into certain types of tissue. But what we want is a pluripotent, which means it can turn into any type of tissue. And that's what an embryonic stem cell can do. But as we said, the problem with embryonic stem cell is they can cause cancer. So there's risk with it, in which obviously we always want to do no harm. So that's why embryonic stem cells are not recommended, even though there are some clinics offering them. You have to be careful because they can be dangerous and there can be a risk with it. Whereas mesenchymal stem cells at least are safe, but they're not always effective because they're only reducing inflammation and they're not really regenerating tissue. So how do we overcome this problem? And that's really been what I've been trying to figure out. And there's something called Yamanaka stem cells, which are induced pluripotent stem cells, which basically you use what's called cellular reprogramming. This is a Japanese discovery. They won the Nobel Prize. It was kind of a big deal because they figured out how to make an old cell young again. So it was really cool. But the theory is cool, but the practicality is still kind of not there, because the problem is when you make an old cell young again, it has a risk of causing tumors or cancer. And so again, there's this risk with that. So it never really took off. Like the iPSCs or Yamanaka stem cells are still in the research phase, no one's really using them in the clinic yet because it's still not there. It will be there, I think, eventually. But there's this other Japanese scientist named Professor Mary Dezawa. And, it's kind of interesting that two of the top stem cell scientists in the world are both Japanese, and they were both at Kyoto University at the same time, which is super interesting. But Mary Dezawa discovered something called Muse cells, MUSE. And these cells are the best type of mesenchymal stem cell. So it turns out that mesenchymal stem cells are not all the same. There's different types. And so but the Muse cell is unique because it can survive in the body and it's pluripotent. So it can turn into all types of cells. So it's a real regenerative cell. So that's why it's so exciting, because we have a real regenerative cell that we're using now. So we're using Muse cells primarily, which is a type of mesenchymal stem cell.
Understood. And it is fascinating, isn't it, that there is such difference worldwide right now between places like the US, and correct me if I'm wrong, but my understanding is that it's still technically not legal, and places like Japan where it's not only legal, but it's even covered potentially by insurance. So we live in separate worlds, right, when it comes to stem cells. Tell us more.
Yeah, you hit it right on the nail, right? So it's basically Japan, because they have so much pride in regenerative medicine, right? So because they won the Nobel Prize, it put them on the global map, right? So then they have lobbyists, they have incentives, they've even invested, taxpayer money into regenerative medicine. So they're really trying to push it forward. And obviously they also have a very aging population. So it's in their interest to want to reverse or slow down aging too, right? And versus, unfortunately, the US and the Western countries have so much influence by pharmaceutical, and unfortunately, there's no regenerative medicine framework or separate entity to regulate that. So it kind of just falls under the same category as drugs, which means that even something as simple as an exosome, which we can talk more about, but an exosome is basically it's derived from stem cells. It's kind of the soup. If you have like chicken soup, I always say the meat part is a stem cell, and then the soup The broth is the exosome. So it has all the nutrients, but there's no cells in there. So there's no DNA material. It's just signals. So it's very, very safe. And exosomes, in Japan have been used for almost 2 decades, and it's legal and is allowed. But in US, it's still not FDA approved. Even as of today, there's no FDA approved exosome product because they're highly regulating it like a drug. And therefore they're requiring, phase 1, phase 2, phase 3 trials, and then post-market surveillance and all this stuff. That takes 7 to 10 years, costs hundreds of millions of dollars. And it just makes almost no sense. It actually makes no sense. And so they need to just copy Japan. I always say that. Like, Japan's already figured it out. They have a separate regulatory framework for regenerative medicine, and I think that's what the U.S. should do. But unfortunately, due to regulatory capture and pharmaceutical lobbyists and all these other issues, unfortunately, the politics gets in the way of regenerative medicine. But that's not to say, if you're American and you're listening to this, you could find 100 different stem cell clinics in the U.S., but they're not offering real stem cells, or they're offering them illegally. So it's, you just got to kind of be careful too, right, in the U.S., and that's the problem.
Because my understanding is that there is a bit of a black market right now when it comes to stem cells, and sometimes I call this stem cells gone bad, right? Because you're not always going to get what you think you're getting. So
I think that's important for people to understand, because that's kind of ruined unfortunately our reputation. And I don't like to be called a stem cell doctor for that reason, because I'm like, no, I'm a regenerative. I do regenerative science and regenerative medicine. I'm trying to do research and trying to push the field forward. But yes, we are also offering treatments. But the problem is there's been so many doctors just kind of, obviously taking advantage of a lot of patients, and a lot of patients who are looking for these cutting edge therapies, and they're not offering real stem cells, because a real stem cell, like we said, is where you actually isolate the cell and then you culture, expand it, and you grow it. And that's still illegal in the US. So if someone takes your bone marrow or your fat and just spins it and injects it back into your body, that's not a stem cell. That's called a progenitor cell, which means it has an ability to reduce inflammation, but it's not really going to regenerate tissue.
And could you explain to us what are the main conditions that can be treated with stem cells therapy?
Yeah, well, if you think about how a stem cell works, then we can talk about what it can treat. So a stem cell works through 2 main mechanisms. Number 1, it works by reducing inflammation. This is called immunomodulation, is a fancy medical term, but it just means that it's reprogramming your immune system from a pro-inflammatory state to an anti-inflammatory state. This has been shown very clearly in the research. It's called macrophage polarization. So macrophages are one of my favorite cells in the body, and the reason is because they're like little Pac-Mans that go around and they eat stuff. They gobble things up, and then they express certain signal, and they're so very important for maintaining your body, because there's always going to be damaged fragments, there's going to be foreign invaders, there's going to be things that need to be cleared out constantly. But sometimes macrophages, just like police officers, they eat, I like to say in my talk, I say, right, like they eat too many donuts, and then they get fat and lazy, and then they can't do their job anymore, and then you start getting stuff that shouldn't build up. And then the macrophages themselves start releasing the wrong signals. They start releasing pro-inflammatory signals. And so stem cells can actually change that back to an anti-inflammatory phenotype, meaning they're actually reprogramming the signaling of the cell. And that's what's called macrophage polarization. So that's one mechanism by they work. So they're regulating the immune system, they're reducing inflammation. And then number 2, they help with mitochondria. And so mitochondria is much more than just the powerhouse of the cell, as most people probably remember from high school biology. They're like little sensors. And they regulate iron metabolism, calcium homeostasis, they regulate apoptosis, they regulate so many different cellular processes, obviously cellular metabolism, meaning when you eat food, it has to eventually go into your mitochondria to be produced into energy. And if your mitochondria aren't working properly, then, it's going to affect everything. And that's why there's something called the unitary theory of aging, which means that we think the biggest driver of aging right now, the consensus seems to be that it's mitochondrial dysfunction. So as you get older, your mitochondria don't work as well, then you become damaged. And then also you lose mitochondria as you get older too. You lose tissue mass, you lose muscle mass, and you have a loss of mitochondria. So that's why there's a lot hot area of research right now is mitochondrial transplantation. But the point is stem cells, they actually transfer mitochondrial DNA and they do what's called mitophagy, which means they help to repair damaged mitochondria. So now you understand that so there's two big mechanisms by which they work: mitochondria and inflammation. And these are two of the biggest drivers of almost every chronic disease, right? And so that's why, to answer your question, it sounds kind of crazy, but it can treat almost any degenerative chronic condition. And that's where it becomes really hard for regular doctors to understand, because if you're a gastroenterologist or you're a neurologist or you're a hepatologist, if you're a different specialist, you think in these little boxes, but that's not how the body works in chronic diseases. It turns out there's certain underlying hallmarks. They're called the 12 hallmarks of aging, and they govern almost every chronic disease process, and stem cells help to target those hallmarks of aging. And that's why we can use them for osteoarthritis, for neurodegenerative conditions like Parkinson's, Alzheimer's. Like, you can use them for rheumatoid arthritis because autoimmune conditions. So the list goes on and on. So anything really degenerative in nature can be treated by mesenchymal stem cells, and, especially these mu stem cells, because of their ability to survive and really change the signaling profile of cells.
And they're particularly efficient to help with chronic pain, right?
Yes. That's where we've almost, I would say now we pretty much can treat anyone with chronic pain pretty effectively, whether that's neuropathic pain or just, soft tissue pain.
Mm-hmm. And I would like to hear more about perhaps another type of user case. And that's one that I heard from clients. I work with athletes too, and I know quite a lot of them have had performance-based anxiety treatment down, so more working with the vagus nerve. Can you tell us more about how that would work, and perhaps how that could work as well in the corporate world? Because I think we have an understanding that stem cells go-to is for athletes, right? High performers in the sporting world, naturally, because they have injuries, they have performance-based anxiety. Well, couldn't that be true for corporate executives as well, traders, lawyers, anyone working in leading organization? Because we have performance anxiety too.
Yes, exactly. Well, not only do they want to be, a lot of those people are high performance, want to be peak performance, but also performance anxiety for sure. So we do a procedure using regenerative medicine principles for what's, as you said, the vagus nerve. So this procedure has been around in medicine for over 20 years. It's called a stellate ganglion block. It's basically, the stellate ganglion is this little chain of kind of nerves or neurons that help to tell your body to go into fight or flight mode. But some people, after they have trauma, PTSD, or they have anxiety, their body goes into fight or flight very easily. So it goes into that fight or flight mode too much, or their resiliency isn't enough. So they're easily go into that kind of mode, and sometimes they can't control it. And it's because it's physiological. And so, for some people, they try therapy, they've tried medications, they've tried a lot of different things, and it doesn't always make a big difference. And some people, it's more physiological anyway. So you need an intervention that's based in physiology. And so what we do, instead of just because what traditional doctors do is they put anesthetic into the stellate ganglion, which does work, it blocks it, but it only works for like 3 months, maybe 4 to 6 months if you're lucky. And then you have to keep repeating it. But what we do is we're not only injecting the stellate ganglion, we're also injecting the vagus nerve, because the stellate ganglion is a gateway to your sympathetic nervous system, which is the fight or flight. And then the vagus nerve is a gateway to your parasympathetic nervous system, which is relax or digest, right? So basically, we're modulating or fine-tuning both of them. So we're down-regulating the fight or flight, and then we're up-regulating the vagus nerve. So we inject exosomes and peptides into the vagus nerve because that increases signaling, increases tone, and up-regulates the function of it. And we also use peptides when we inject into the stellate ganglion, because then you're actually going to have this change in signaling pattern that's long-lasting. And that's what leads to long-term results from what we've seen. And we've done it for hundreds of people, and it's kind of become our most popular procedure. And to your point, like I've done it for pro golfers and people who have high-performance sports and sometimes have that performance anxiety and they can't always control it. But I've also done it for many lawyers and and other people like that, because some lawyers have high-stress jobs, demanding. And it can just increase your stress resiliency, your mind-body connection. It can improve your HRV, your sleep, your recovery. So there's a lot of benefits to it. And I think it's one of those procedures I hope one day will be really covered by insurance, because I feel like there's so many veterans we've helped with it. with people with PTSD and severe trauma from obviously being in the wars or going abroad and being deployed. And people like that have benefited greatly from it. And one of the things we're trying to do is get this covered by insurance. But again, they're always so slow to adopt. But it can be a life-changing procedure for people with PTSD especially.
Yes, and from the standpoint of looking at a patient's journey, being a clinical hypnotherapist, I find that fascinating because it's so complementary. Yes, you can work with the mind and you can do timeline therapy and you can do clinical hypnotherapeutic interventions. But then if you also work at the root cause, at a physiological level, those two interventions can work so well together.
Yeah, that's exactly what it is. It's synergistic, and they work so well together. And if you think about it, whether it's being, the hypnotherapy or any form of psychotherapy, really, if your body has a less physiological, if you're not in that fight or flight, you can do better therapy. Just logically, right? If your body's in this adrenaline, high cortisol state all the time, it's really hard for you to get your mind-body connection and go into that kind of therapeutic relationship that you need with your therapist.
But from the standpoint of being quite time poor, right, which is the curse of all high performers, a curse or a gift, I don't know which way to look at it, it is just super attractive because now we're saying, get this done, we're actually working at the root cause of the anxiety, and then you will have the holistic journey of being seen by a therapist, psychotherapist, hypnotherapist. So what we've done really is work holistically from the ground up, so to speak. Is that correct?
Yeah, exactly. And that's why the combination can be so powerful, especially with the right therapist.
Absolutely. Now, I have perhaps a controversial question to ask you, but it is on people's minds, so I thought let's go for it. One of the reasons I hear perhaps a bit of fear or skepticism around stem cells is the controversy, and I know it's quite an old controversy, but it's still present in people's mind at a societal level around the sourcing of the stem cell and around, is this something that we need to be concerned about ethically? Could you shed some light on those concerns?
Yeah, the ethics issue was during George Bush's era, which was like mid-2000s, because there was this whole discussion of embryonic stem cells. And embryonic stem cells come from fetuses, typically aborted fetuses, and obviously that's controversial. Or are you just creating fetuses or embryos in the lab simply so you can take their stem cells and then they die? And obviously that's also very controversial and, in my opinion, unethical. And so I've never been a fan of embryonic stem cells for the ethics, but also, like we talked about, embryonic stem cells also can cause cancer or tumors because they have too much pluripotency, which means they can keep replicating and they can form tumors. And so because of that, embryonic stem cells to me are unethical, but umbilical cord stem cells are literally just products that are perinatal tissue, meaning after birth, they're either going to be thrown out or they're going to be stored. So you can throw them out, but we don't pay people for it because that can also create it. And people just have the option to donate their stem cells basically, or they can, because some people store them for themselves and but a lot of people just throw them out. And that's kind of been traditional medicine, right? Like the umbilical cord tissue was typically just thrown out with the placenta and everything else. But now we know that this stuff has a lot of healing properties. So let's keep it. And then let's isolate the good stuff like the mute cells from the umbilical cord tissue. And that's what we can use to inject. And there's a lot of control in terms of testing to ensure that it's a safe donor, because this stuff has been done for over 20 years now. And we know, obviously, the standard infectious disease testing, but in our case, we also have unvaccinated donors, and we test for EBV, CMV, Lyme. We do additional testing that a lot of labs don't. So and our factory is also approved by the European government in Lithuania, and it's approved by the European Medical Agency. They're AMTP approved. So it actually, interestingly about insurance, if you're an EU citizen, you can get reimbursed in our clinic in Lithuania because it is approved by the government there. Fascinating.
Now, I would like to ask you a question, Dr. Khan. Let's imagine I'm pregnant right now and I'm due to have my baby in New York because I live in New York. But I really want to work with you because I really want to be storing my umbilical cords, but I'm not able to travel to Lithuania or Dubai or Canada or anywhere where you are or your team is based. But I want to work with you. Can we make that happen?
Yeah, we actually have a stem cell bank we're working with. It's called Future Health. and they have locations all across the world. They started in the UK. They are the largest cord bank storage in Middle East and in UK, from what I understand. And so basically you can, let's say, hey, I'm having a baby and I want to store my stem cells and I want to use my immune cells for my baby or for myself. You could have them store it, and then we can have that there for you if you ever need it.
That's really good to hear. And do you find that in your experience, if we use my own cells,
it doesn't matter actually, because the beauty of these cells, especially the immune cells, is they're hypoimmune, which means they're immunoprivileged. So they don't trigger your immune system in any significant way. They don't cause rejection. They're perfectly safe, and they're not going to cause any problems in terms of causing your immune system to overreact to them. Now, there may be a case to be made that having your own stem cell, like if it's from your own blood, from your own child, the only advantage might be if it's a complete match to your what's called HLA, which is HLA antigen, which is basically a marker to tell your body, is this something I need to attack and get rid of? So basically to tell your body, is this something that belongs in my body, or is this something that doesn't belong in my body? And the good thing about the thing with donor stem cells is that the HLA expression is so low that that's why it doesn't cause immune rejection. But there still is a little bit of HLA expression, which means that eventually these cells are cleared out, and usually within a few months. So the only theoretical benefit of having your own child would be maybe the stem cells will stay in the body longer. So there may be more long-lasting benefit.
So let's say I've donated my umbilical cords tissue to Future Health for my own user case scenario, for my family. How long are they going to last, and how many stem cell injections?
They're cryopreserved, liquid nitrogen, yeah.
So I can use them for my child if he happens to then turn out chronic pain down the road, right? This is one of the best gifts you can give your baby. I know that most people open up a trust fund, but I feel like I want to open up an umbilical cord donation instead.
Exactly, yeah. That's why the cord bank, they're becoming a huge business, right? Because people are starting to realize, they're like, hey, I should just keep this in case I need it down the road. And it's becoming more and more popular, yeah.
Super, super good news. And so I'm really interested about that because a lot of my clients are actually going through pregnancy right now. So I just want to make sure we capture this information at the right time before we've donated the umbilical cords and now use them the way we want to use them, or to encourage folks out there to donate it because it sounds so terrific for the advancement of medicine. But my question is, if I were to use umbilical cords tissue from that one birth, how much of it do I get? So how many sort of stem cells injection can I get out of, roughly?
You can get like several billion stem cells, which means we're talking like, let's say if you wanted to do an IV of stem cells, usually a high dose would be like 100 million new stem cells, for example. So you're talking like 10, 20 dosages, which is a lot. Yeah, so
that would be potentially enough for yourself, for your husband, and
for your family, exactly.
For your whole family.
Yeah.
What are you doing for Christmas? Are we getting our own stem cells?
Yeah, exactly.
Cool.
Yeah. No, I'm excited to work with that banking company, just because then a lot of my patients always ask me, because they're always like, oh, is there somewhere I can go? And before we didn't have it. Now we have a cord bank partner that we can kind of rely on to store people's umbilical cord tissue, and we also have the access to the technology where we can isolate the immune cells should we ever need to use that.
Right, I see. And so let's talk about Japan, for example, because it's so, can we say mainstream or not quite yet? At least,
there's stem cell. There's stem cell clinics everywhere in Japan,
right?
And they're culture expanded stem cells. So obviously they're not the ones you get in the U.S., not the fake stem cells.
So does that mean that mothers to be are more aware of potential donations or?
Yeah, I think it's ingrained in their culture, to be honest, because they've been used, for example, like umbilical cord exosomes there have been used for like over 10 years. So I think people are very familiar with the whole concept of using umbilical cord tissue and perinatal tissue and birth products for healing and regeneration. And they like to call it rejuvenation. So they're very familiar with that whole concept. So I think it's much more ingrained into their culture versus our culture is still very much, not like, I think it's still not in the mainstream kind of zeitgeist, so to speak, that people know that, hey, this is something I should store and keep for later.
Right. I see. And now the question I wanted to ask you, Dr. Khan, is obviously stem cells therapy is just terrific when it comes to helping with a chronic condition, chronic pain, etc. But what if everything's fine? I'm not in pain per se, but I really believe in optimizing my body and preventive potential damages or slowing down the rate of aging. Is there a user case for preventative stem cells therapy when everything's fine, but you just want to get to the next level of performance or health?
Yeah. That's why I use it personally. I'm a healthy person, but I like to stay youthful, and I'm a good example because I feel like I have a pretty youthful appearance, and I feel like a lot of that has to do with the stem cells I've been using, and also with obviously a lot of my patients. They're successful, they've accomplished everything career wise, and now it's about their health. Their health is their priority, and a lot of them are healthy, but they want to stay that way as long as possible. And so that's where this longevity interventions come in, which is basically, honestly, it's so simple. It's just an IV of your Muse cells and Muse exosomes, and you just put them IV, and we combine it with something called umbilical cord plasma, which is, again, another birth product that's just plasma that has been shown to help with DNA methylation and help with signs of biomarkers of aging. And it just goes in an IV. You sit there for 1 to 2 hours, and you can do it every 6 months to 1 year, or some people you can even stretch out to every 18 to 24 months. So it varies. There's some people who want it more often. Other people are okay once every year. But the point is, what it does, it does slow down aging objectively and subjectively. So what do I mean by that? Objectively, we can measure your cellular aging. So cellular aging, I'm sure you've seen those tests, right? Where it's like your biological age is 50, but your chronological age is 55, right? And it's like, but most of those tests are not accurate because they use something called linear regression, and aging is not a linear process. It's non-linear by definition because you age faster at 70 to 80 than you do at 20 to 30, for example. So that's just one reason why these tests aren't accurate. But the other reason they're not accurate is because the way they're actually measuring it, they're just using something called DNA. They're just using, data sets based off methylation. And that's actually not the most accurate indicator. What the most accurate indicator of aging is what's called DNA damage or genotoxicity, which is accumulation of the damage of the nuclear DNA. And you can measure this, it's called biological noise, which is that over time, your genes make more mistakes, right? So what happens over time as you get older, your DNA accumulates more damage and it starts making more and more errors. And then this is called biological noise. So there's more noise and there's more variance and there's more mistakes being made. And this can be measured now. And so this is called biological noise. There's a company called Regeneration Lab that we use their kits because we can measure this. So we have objective data. So let's say you come in, your speed of aging, let's say is like, it's faster than it should be. And then 6 months later, you do the IV and then you can repeat the test. And then you can see objectively, hey, I slowed down my aging by this much. So you have objective data, and then subjectively, people usually feel better recovery, better sleep, their HRV improves, and they have more energy, and they might have more mental clarity, better memory, better constant focus. So they actually feel younger too, which is really cool. Like they actually say I actually feel 10, 15 years younger because they have all these better kind of like more energy, less pain, those type of things that go with aging.
So if we're talking about peak performance, whether it's athletic or whether it's in the corporate business world, this is the thing to do, right? If you're really looking to take your performance and health to the next level, and
once you have the basics down, like most people at that level, they know about exercise, sleep, stress, nutrition, supplements. They're doing all the basic stuff, and they've optimized that. So then it's like, what else can I do, right? And this is kind of the next frontier,
yes.
I would say, yeah.
So you've alluded to having that done for yourself and being very healthy and doing it in a preventative user case scenario. Could you tell us more? I'm really curious.
Yeah, well, I mean, obviously now that I'm getting labeled as a longevity doctor, even though I still consider myself more of a, sports medicine, interventional pain, because that's my specialty. But obviously we do a lot of longevity work now. It's always about I want to obviously look and feel young myself. I've always been into that. And natural bodybuilding is the way I do that. Like I'm very into fitness, and I think that's still the foundation. But what to me, it's like, how do I maintain my health of working out hard and recovering as long as possible? And that's what these IVs do. They help me with, and I travel a lot. I'm all over the world, and I have a crazy schedule. So it's like, how do I need to be somewhat resistant to fatigue because I'm not always getting the sleep I need. And so I find this stuff really helps me with energy and recovery. And it's something I do personally every 6 months. And, we also do for the face. So like we do the Muse stem cell facial, which is very popular as an alternative to Botox or fillers, because obviously that stuff is just like very temporary and it weakens your muscles. Whereas the Muse stem cells actually help your skin to become healthier at a cellular level. Aside from the cosmetic benefits, your skin is actually a very important immune system regulator, because your skin is kind of a barrier, right? And so if your skin isn't functioning properly, your skin cells aren't functioning properly, it's a kind of a gatekeeper for your immune system too, right?
So you haven't had Botox or anything like that? You use stem cells?
Yeah.
Well, I just want to clarify for our audience, because I think the video camera doesn't do you justice, but I've met you in person and you look so youthful.
Yes,
I was actually amazed by how incredibly healthy your appearance, your skin, and your disposition overall when we were, sharing the stage. So I just want to say, in case it's not as visible on camera, obviously, it's quite remarkable when we meet you in person.
Yes, thank you. Yeah, I'm working with a lot of Hollywood celebrities now, and that's actually been their selling point. They're like, "Hey, what do you do?" And I'm like, "This is right."
Well, I'll be honest, Dr. Khan, that totally got my interest.
It's funny. It's
that.
Yeah, exactly. It's funny how well that works. But I guess I'm personally, I think it's important too, though, to be honest. If it's like a personal trainer who is overweight and they're trying to give you exercise and fitness advice, and nutrition, you're just not going to take them as seriously as someone who's in good shape, right? I think it's just a human bias. Even the person who's not in good shape, they might know everything, but we just have these cognitive biases where we tend to listen to people who, practice what they preach, right?
Absolutely. And I think it's important to know that there are different avenues to youthful looks. And it's not necessarily what we hear the mainstream Botox go to. I've made that mistake. I'll be totally honest. I've had Botox injections and I've actually really regretted them because I noticed that when I stopped, then I had to do more and more. So I just quit completely. And I'm glad that I have. But I'll be honest, it actually sort of set me back in a way when I look at where I was compared to where I am. It's made it worse, which is really frustrating because now I've stopped.
Yes, exactly. Because there's a good saying, Botox is like a cult. Once you join, you can't get out, because if you stop doing it, then the muscles start atrophying and they're not as supple as they used to be. But luckily, the Muse cells can fix that. So we'll get you a good facial and get that.
Oh yes, let's. I'm on it. I'm coming to Lithuania. For sure. I'm really glad that we've had that conversation.
Thank you so much for tuning into this episode with Dr. Adeel Khan. I hope that you've enjoyed this incredible conversation and picked up some new insights into the exciting world of regenerative medicine. If you're curious to learn more about his work or explore the regenerative therapies he offers, please do head to the show notes for links and resources. There you'll find more details on how to connect with Dr. Adeel and dive deeper into the cutting-edge world of stem cell therapy. And if you have any more questions about the treatment that Dr. Adeel Khan offers at his clinic, please do not hesitate to reach out to his team at Eterna Health Clinics. All the information in the show notes. Thank you and see you next Wednesday.